we're going to do a problem using some conditional probabilities. So for this problem, we know that the probability of event A is 0.5, the probability of event B is 0.2, and the probability of event, or if we know that B has happened, then the probability of A is 0.7. So this is our conditional probability. We read this as the probability of A given B. Again, this means we already know that B happened, then the probability of A is now 0.7. Okay, so for 35 it asks us, what is the probability of A or B? So to do this, we think, well, do we know a formula for the probability of A or B? We do know a formula for that. The formula is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Remember, we need to subtract out that intersection, the probability of A and B, so that we're not double counting. So we know the probability of A, we know the probability of B, but we don't know this probability of the intersection, so let's find that first. So we need to find the probability of A and B. Now remember, we do have a formula for this. If we know a conditional probability, and we do know a conditional probability, we know the probability of A given B. To find the probability of intersection, we can times this by the probability of B. So we times the given, so we have our conditional probability with the given, and we times it by the probability of that given. So B, B. And so let's plug this in. So this would be 0.7 times 0.2, which should give me 0.14. Let's just check. 0.14. So that's the probability of A and B. So now back to our probability of A or B. So probability of A is 0.5 plus the probability of B, which is 0.2, minus the probability of the intersection, or the and part, and let's see what we get. We get 0.56. So that's how we find the probability of A or B. So that was question 35. Let's move on to question 36, where they asked us to find the probability of B given A. Notice here we have the probability of A given B. Now we want to find the probability of B given A. So we basically want to switch those conditional probabilities. This is why people invented Bayes' rule, but we don't actually need to memorize Bayes' rule. We can still just find this using the formulas that we know. For instance, we have a formula that says the probability of B given A is equal to the probability of the intersection, so A and B, or B and A, it's commutative, it doesn't matter which one you write first, divided by the probability of A. So A is a given, that's the probability that we divide by. Now, look up above, we found the probability of A and B, probability of A and B, we found that to be 0.14. Divide by the probability of A, which they told us is 0.5. So it should give me 0.28. 0.28. So if we know that event A has happened, then we know that the probability of event B is going to be 0.28. Notice again that we do have two different conditional probabilities. We have the probability of A given B, and then we also have the probability of B given A.